This video introduces mediation estimands known as natural, direct, and indirect effects. Our goals are to define these causal estimands, decompose total causal effects into direct and indirect effect components, to understand how a notion of intermediate confounding can complicate natural direct effects, and then we're going to learn a bit about how to estimate natural direct and indirect effects. So if you recall from before, we're thinking here about a hypothetical world where we have a treatment. A principal might send a librarian to visit some classes and not visit other classes. When the librarian visits classes, that may affect the value of a mediator, M, whether kids choose to visit the school library. And that may in turn affect the value of an outcome, Y, the degree to which those kids are reading books. Now, sending the librarian to visit classes may increase kids reading books through an indirect effect. The librarian visits the class. This causes the kid to visit the library, which causes the kid to read books. And also through direct pathways. Any other pathway, such as the librarian visits the class, the kids get excited about reading and they go read some books they have on their bookshelf at home. We talked about two direct effects previously in the video on controlled direct effects. The first is the direct effect in a world where we close the library. This is the expected rate of kids reading books in a world where the librarian visits their class versus the librarian doesn't visit their class. But in both cases, we prevent the kid from visiting the library. This is the contrast of potential outcomes where the treatment, A, is set to the value 1 versus 0, but the mediator, the second term in this potential outcome notation, is set to 0 in both cases. In a hypothetical world where we prevent kids from visiting the library, the only way the librarian visiting the class can affect whether the kids read the books is through these direct effects that do not operate through the process of the kids visiting the library. Now, we also talked about another direct effect. What about the direct effect in the world where everyone visits the library? You, as the principal, randomly assign some kids to have the librarian visit their class and others to not visit their class, but then you have all of them visit the library. In this world, we're also looking only at a direct effect because the pathway where the librarian visits the class and that increases the kids visiting the library, that's not operational in this hypothetical world because everyone visits the library regardless of whether the librarian visits their class. In this video, we'll think about natural direct effects. These are similar, but with some differences. So let's let M superscript little a be the potential mediator value that would be realized under the treatment A being set to the value little a. So for example, there is one potential mediator value, M superscript 0. This is whether a kid would visit the library in a world where they've been assigned to not have the librarian visit their class. In that world, we can imagine a causal effect for those kids. What's the average effect of sending the librarian to visit their class versus not sending them the librarian to visit their class if we hypothetically had every kid visit the library with the frequency that they otherwise would have if the librarian had not visited their class? We could also ask about another direct effect. What's the average effect of the librarian visiting your class on whether you read books if you hypothetically visited the library as often as you would have if the librarian had visited your class? Each of these are direct effects that isolates the pathway from the treatment to the outcome that does not flow through the mediator. With this notion of natural direct effects, we can decompose a total causal effect into two components. So here we start with the expected value of the outcome under treatment minus the outcome under control, the total effect. Let's rewrite this with potential outcomes defined in terms of the treatment and the mediator values. So the first one is the outcome realized if you're treated, and your mediator takes whatever value it would be assigned to if you were treated. The second is your outcome if you receive the control condition, and your mediator takes the value that it naturally realizes under the control condition. So here we've just redefined our potential outcomes to have both the treatment and the mediator. Now we're going to add 0. This is just the same term here and here. Why are we doing that? We're doing that because it allows us to make a decomposition into what's called an indirect effect at the left and a direct effect at the right. So let's first start at the indirect effect. In the indirect effect, we have kids hypothetically assigned to have the librarian visit their class in both cases. We're contrasting the outcome that would have happened for those kids if they visited the library at the rate that they would have if the librarian visited their class, versus if they visited the library at the rate that they would have if the librarian had not visited their class. And so thus, we estimate the degree to which the treatment affects the outcome through the mediator, because here we're looking at the outcome where the treatment is set to 1 in both cases, but the mediator is set to the value that would be realized if treated, and then the mediator set to the value that would be realized if untreated. This second term of the decomposition is the direct effect. This tells us the effect of being treated versus being untreated in a hypothetical world where your mediator visiting the library, it took whatever value it would naturally have realized if you were not treated. This is a direct effect because it contrasts two values of the treatment, with the mediator fixed to some value that's the same in both treatment conditions for any particular child. So let's go through those interpretations here with the DAG on the screen. So our first estimand here is this indirect effect when the treatment is set to the value 1, and our second is the indirect effect when the treatment is set to the value 0. So this first indirect effect is the effect of visiting the library as much as you would if the library did versus did not visit in a world where the librarian visits your class. The second is the effect of visiting the library as much as you would if the librarian did versus did not visit in a world where the librarian does not visit your class. These are two different definitions of indirect effects, and they both capture the causal path that goes from A to M to Y, because here in both cases Y changes because M has changed, and M has changed to whatever degree it does because A has changed. So let's think about this in controlled experiments, where we're going to think a little bit about controlled direct effects and natural direct effects. So in a controlled direct effect, we're interested in the difference in the outcome when treatment is set to 1 versus 0, and the mediator is set to the same value in both cases, in this case, the value 1. Now we can observe the outcome y11 in an experiment. We can assign people to be treated and have the mediator value 1. We can also observe the outcome y01 in an experiment. We can assign people to be untreated and assign their mediator to the value 1. Now let's look at natural direct effects. For natural direct effects, we can run an experiment to see y1, m1. This is the outcome you realize when you assign someone to be treated, because for that person, their mediator takes the value mi1 because it takes whatever value it would realize under treatment. This last term is more complicated. This is sometimes called a cross-world counterfactual. This is a term that cannot be observed even in an experiment. So why is that? Well, this is the outcome you would realize if you were untreated, but your mediator took the value it would have realized if you had been treated. So that's confusing because this is the outcome in a world where you are untreated, but the mediator takes the value it would have realized in the counterfactual world that doesn't exist in which you had been treated. If you assign someone to be untreated, you'll never see M1. If you assign someone to be treated, you'll never see Y superscript 0. And so this Y0 M1 is a very difficult term to study. Now, sometimes people make progress by drawing on an experimental solution with an additional assumption. So this solution is called a crossover design, where you have an experiment that proceeds in two periods. So in the first period, you assign treatment to some value little a, and you see the mediator value M superscript a that's realized. In the second period, you assign the other treatment condition, A prime. Then you also assign the mediator to the value M superscript a that you learned in period 1 is realized when the treatment takes the value little a. So we then get to see the potential outcome Y under treatment A prime and mediator M superscript a. Now what makes this work is an assumption of no carryover. It's an assumption that whatever I did to you in period 1, it doesn't affect your outcome in period 2. And this may or may not hold in various settings. In general, it's important to realize that natural direct effects involve this cross-world counterfactual that you can only study under particularly strong experimental conditions and assumptions. Observationally, intermediate confounding can be a threat to identifying natural direct effects. In a second, we'll come back to how in observational studies, there's a particular assumption you can make that lets you study natural direct effects also. Okay, so let's first worry about the setting where we have intermediate confounding. So here, whether the librarian visits the class affects an intermediate confounder Z, whether kids like to read books, and that affects whether the kids visit the library and whether those kids read books. This is an intermediate confounder because A affects Z, which affects Y, and Z is a confounder of the M-Y relationship. So if Z is measured, we can identify the controlled direct effect non-parametrically, as discussed in the video on controlled direct effects. But even when we measure Z, we still can't study the natural direct effect. It turns out that in observational settings, to study the natural direct and indirect effects, you have to assume that there are no intermediate confounders. It's not just that you have to measure them, there have to be none at all. And so why is this the case? Well, if you think about the CDE, we can identify the expected outcome under Y10 by looking at people who had the mediator value 0 and the treatment value 1 within a subgroup defined by Z. And then we can average across those subgroups in order to capture the effect that flows from A to Z to M to Y, as well as A to Z to Y. For the natural direct effect, we would have to know the outcome in the M0 case for the treated people. But as just discussed, this is a cross-world counterfactual that we never get to see. And so in these settings, we don't actually get to do something that lets us incorporate this intermediate confounder to identify natural direct and indirect effects. Instead, we have to assume we're in the setting where there are no intermediate confounders. In this setting, the natural direct effect is non-parametrically identified. So the expected value of the outcome under treatment value 1 and mediator value M0 that would be realized under the untreated condition, what does that equal? That's the expected value of the factual outcome among treated cases whose mediator took the value M superscript 0. Okay, well, that was just sleight of hand because we never get to know if the mediator took the value M superscript 0. But there's a trick we can use. We can actually break this out by the law of total probability. So there is some probability that M0 equals 1, and we get to see people with the mediator value 1. There's some probability that M0 equals 0, and we get to see people with the mediator value 0. And further, we can actually estimate how many people there are for whom M0 equals 1 by the rate of M equals 1 among the A equals 0 people, because we've assumed that we have, in this case, no confounding of AM. In more general cases, you could adjust for measured confounding in this step. Likewise, we know the probability of M0 equals 0 because we can identify the causal effect of A on M. And so there are no potential outcomes that remain, and so we've non-parametrically identified the natural direct effect in this setting where we have no intermediate confounding. So this suggests an estimation strategy for natural direct effects when this assumption of sequential ignorability, that basically all the stuff gets ignorable once you control for the pre-treatment confounders. In the setting where that holds, we can estimate the natural direct effect by a simulation procedure. So this procedure begins by first modeling how the mediator responds to the treatment within subgroups defined by our sufficient adjustment set X. We then predict the mediator value that would be realized under every possible treatment condition. Then we model how Y responds to the mediator M while adjusting for X and A. We then predict the outcome realized under each treatment value A of interest, with the mediator set to the potential mediator value predicted in step 1. That's the one that you're interested in for your natural direct effect. Then finally, once we've made those predictions, we can average over the sample. And you can bootstrap this whole procedure to produce confidence intervals. So the paper cited in the footnote is a great reference that will help walk through these steps and help you think about the settings when sequential ignorability holds or when it might not hold. So to summarize, mediation is all about decomposing causal effects into direct effects and indirect effects. In one video, we talked about controlled direct effects, where the idea is to intervene to hold the mediator at some fixed value that's shared for all the people in the study. In this video, we talked about natural direct and indirect effects, where the idea is to intervene to hold the mediator at some value that would have been realized in the absence of treatment. Each of these approaches has its own strengths and weaknesses. Controlled direct effects are identifiable under a broader range of conditions, but natural direct and indirect effects have this nice feature that they are able to fully decompose the total causal effect into components that are direct and indirect. So depending on your setting, you might prefer controlled direct effects or natural direct and indirect effects. And that's it for this video. We've talked about natural direct and indirect effects, how to use them to decompose total effects, what kinds of assumptions we need to make for natural direct and indirect effects, the absence of intermediate confounding, and then we talked a bit about how you can estimate.